Good evening. Welcome. Thanks for joining. We're back for another dev update for Ortunia Mysteries VR Edition. This is where we're taking the PC version of Ortunia Mysteries, which is available on Steam right now, and converting it slowly into a VR experience. It's been an interesting process doing that for sure. There's certain things that worked really well on the PC version that don't translate so well on the VR version. We'll go through, there's maybe 3 or 4 major changes and then a handful of smaller changes that we'll go through tonight, and we'll go from there. So without further ado, let's get started. And a couple of the things that we'll notice off the bat from our last devlog is our hands. We had a problem with the devlog last time, and where our hands were oriented incorrectly. Anyone that's played any VR knows that when you're holding your controllers like this, your hands should be oriented like this, where previously we had ours up like that. So you can see this has been fixed, and in a moment I'll show you the setting on the Hexabody prefab and the Hurricane VR setup I'm using in order to fix that. Yeah, it is just a setting in the editor, but it was pretty hidden, so we'll go through that. All right, for the hand rotation issue, as I had mentioned, there's a setting that fixes it that is quite hidden. It took me a little while. I actually got into their code and was doing debug statements in order to find it. However, we've got our Hexa 4 rig backpack prefab. This is our player. When we go down here, we have our Hexabody. And this is where it gets a bit odd. We have the pelvis section, and underneath that we have the camera rig, believe it or not, the floor offset, scaler, and we have then items for our left controller and our right controller. Under those, we have our left and right offset, and in here, we have our HVR controller offset. And we can see now on this setting, miscellaneous rotation offset, I've got an X value of 90 degrees on both of these. This actually rotated the hands properly and have them oriented the correct way so that we are pointing forward when our controllers are in a natural position. What's interesting to me here is that it's in a debugging section, which kind of just shows how a lot of us devs work. You know, we come up with something that we originally think is as something just to help with the debug or with the debugging and the development process, but then later we realize that it's actually useful and just leave it in. At least I kind of assume that's what happened here. It's a little odd using a debug setting for this to fix it, but in the few posts that I eventually found after the fact finding this, it was stated that this is the right way to kind of fix this. So it's an interesting thing. So if you're using the Hexabody package, just something to know. Hexabody with the Unity in the way I've got it set up. I suspect that some other type of VR device, I'm using the Meta Quest. I suspect another VR device likely wouldn't need this, and it was tested against that as opposed to this one. So here's the first view of lighting the candle with the fireball. And it's very simple. We just aim at it, and we can see we've got a little bit of an indicator that the candle is able to be lit right there like that. And just hitting the trigger, we fire it, and it lights. This particular candle...
Help! Driven, help! I don't know what they are.
Here.
They are hideous. They are after us. Avoid them if you can. I'll do my best, but find us.
Joran! I have to find a way out of here.
So this particular candle cannot be extinguished after, so if we point to it now, we don't get the little glowing bits. This one is now lit, it can't be unlit. We'll see in a little bit a number of places where we're able to light and extinguish. It's the same sort of thing. We'll send a fireball towards it to light it, and then again we call the fire back, and yes, we'll see that shortly. So you can see the torches, and as we know, there's a puzzle related to the torches. They need to be lit and extinguished in a certain way. And very similar to what we showed a little bit earlier, we can point our hand to the torch, and we get the almost like fireflies going around it, but it's the twinkling. And again, using the same trigger, we will call the fireball back to our hand and extinguish it. And we can then do it again the other direction. This allows us to just constantly pull it and shoot it. As you can hear, we have a sound that allows us, or that shows that we've lit it. I do want to have some sort of sound when it's coming back and extinguishing. So all of these are the same, and we can do both hands. I wonder if that will work now. Yeah, and this is kind of it shows that we got a few bugs still. However, what is development without some funny visual stuff like that? So this kind of makes me look like a cool little wizard with just playing with the fireball in my hands, but hey. And just for anybody that's interested, I can give a little bit of an update on how that works. I have this VR torch lighting node now in the tree. We've got our fireball. We've got our selectable object effect left and right. I've got two of these, one for each hand. It just, the way the code ended up working, it was easier to kind of duplicate the item and have one for each hand, as opposed to trying to use the same one. If we look at these, this is just a particle system with a specific set of parameters to get that kind of sparkly, feeling, or the sparkly look that we see when we're pointing at it. The fireball is very, very much the same as our torch fire. That was purposeful to kind of have the same look and feel as it gets lit. So we've got the same sort of thing. Additionally, it also allows us to light and extinguish the fireball in the same manner as the torches, so using the same code. We also have in our Hexabody prefab, our player, I should say, under our hands, the physics hands, we have our hand models, and under those we have these, it's called the ray origin. And this has got our fire target controller script that we'll just briefly look at. This script allows us to target, it is what targets the lights. It sends a ray, and we'll take a look at the code, but it sends a ray, and if it's in the right range, we'll then trigger the particle system that gives us our effect. It also allows us to choose the fireball. There's a particle offset that's in there, but we actually have this added to the different spots now. This was a piece that needs to be removed. It was kind of the first attempt. The more permanent solution is on the items that can be lit this way. We now have a lightable object data script that is exclusively for this offset, so that we can know where that particle system should be. For example, these torches need to have a little bit of an offset both up and out, so that it's in the spot where the light should be. Where some of the candles, it's pretty much right at the center, 0, 0, 0. So yeah, let's just take a look at the code itself. And so we do have our fire target controller here, and we'll just take a very brief look at it. We've got a distance that the fire can travel. We've got our reference to the particle system. We're using a layer in the game. If we go back quickly to Unity, we can see that the torch is in fact on the torch layer. This is what allows us to light it, and not the fact that we can take this torch out of the torch layer in code and prevent any more lighting or extinguishing from happening is what's used in numerous places in the game to prevent that once, a puzzle is solved. And then we've also got our particle offset, our fireball, and our current target. As I said, this particle offset isn't used anymore. It's the specific one on each object that's used instead. And then we've just got a kind of a Boolean to know if the fireball is being shot or recalling. And then, yeah, as I said, we create a ray just coming out of our coming out of the hand that this is attached to in the forward position, and we shoot the ray on this particular layer at most this distance. And if we have a hit, we just check to see if the hit is in the current target, and if it's not, then we turn the particle system on right here and have that sparkle. Once we lose the fact that we're pointing to it, we then clear the target and the particle system comes off. We also then have in our fixed update the code that actually moves the fireball to the right spot. I won't go in detail, but this is where this code lies, so that we get the smooth transition to the new spot. We've got just a couple other functions that really aren't that interesting. When we are actually shooting the fireball, this is just to actually set the fact that we're shooting, that we're active, making the fireball active so it's visible, checking where the position should be, and then this change fire, which actually lights it. So and there's a similar one for recalling. So yeah, just a very simple solution. It did take me quite a while to get this working properly. Part of the problem was the hand position that we talked about earlier in the video, with where it's pointing. But once we got those hands corrected, it just took a while to get the particle systems working properly, the fire going to the right spot. And as we saw in game, there's still some problems, obviously, where there's something being crossed in some of these fields, probably but the fact that we're using this controller for both the right and the left hand, and that there might be some of the object or the parameters that are shared. So anyways, it's some interesting things that we'll have to figure out over the coming weeks. So yeah, maybe on the next one of these updates, we will see this working even more, and we can figure out exactly why the fireball wasn't completely working the way we thought. All right, so we're in our room 2 that, I've named this room 2 in our chapter 3. And I just want to focus a little bit on this black smoke. Of course, if you've seen before, we can walk onto here and just have it stop. There we go. But of course, we don't hear our correct action sound for the puzzle, so we know that's not the answer. And of course, we know that using these big urns allows us to fix this. Now, the issue that we saw last time was that when we dropped these, they would disappear. However, I fixed that, and I thought it was interesting just so that we can see and show what was causing it. But if I drop it, we now have it sitting properly on top of the trigger there. Let's grab one more because we need another one. There we go. And we'll just put it on this one as well. And that opens up our coffin. So visually, what was happening was, you saw, maybe you didn't see, when I was carrying them, I had my hand upside down and was dropping them from the top to, from the top instead. And with our code to move the pots to the right position, they kept the orientation, and therefore we're actually in the floor. So it was a very simple fix code-wise, and we'll swap to that now. But it's a fix that you just have to change the rotation to the quaternion identity, and we've got that. So let's just take a quick look at the code there. All right. Now we're going to look at the code. Here we are in our room outside the game. There's our couple of pressure plates. Let's take a look at the code. Okay, and here in the code, we've got a couple conditionals here. This particular code isn't interesting. It's just testing a collision, whether or not the dark fog and the container are colliding. And I will also cover this drop held object by tag a little later in this video. Right here, it's our code change was in our resolve dark fog trigger. And very, very easy in this specific spot here. We are now, instead of just setting a position, we're actually setting a position and the rotation. We're putting the position is to be the same spot as the pressure plate, but we're using the quaternion identity. And this was, again, just a difference between the PC version and the VR version. In the PC version, the rotation we could set when the player dropped the item, whereas now with it being hands, we don't have the control. I mean, we could get the control by overriding the code, the hand code, but in this case, it wasn't necessary. We can let the player rotate it, throw it around, whatever. We can set the rotation to the desired identity rotation when the collision happens, and we get the functionality that we saw in game.
Well, I guess I'm kind of stuck. Where are you, Joran?
Okay, here we are in our chapter 2. We can see we still have our temporary line shooting out of our hand. This is not going to be part of the final build. It certainly is easier having the controls in the right direction, that our hands are in the right direction instead of like this. When we're wanting to point to something, it's much more obvious that way. I do want to kind of use this sort of thing, though, not like this. When we're pointing at something and we get the dot, we can see it there. We just have a faint line, like a pixel sort of width. Just a faint line saying, yeah, that's actually something you want to pick up. We'll just put this in the backpack as well. Grab the other skull. Okay, let's go place these, and then we can show off the change to the swords. All right, so our shield here is where we were talking about. Let's grab one of our swords. Okay. The bug that was there was when we touched this sword to the shield, if we were still holding it, it would force the player into the wall, like right up against the wall. We know now when we touch this, it then doesn't pull us. Let's do it one more time. I'll stand over here. It doesn't pull us to the spot. It just puts the sword there. Let's take a quick look at the code that shows what we did there. It's something that you'll want to implement if you're using the Hexabody if you're using the Hexabody package in Unity. You'll probably want to do something similar if you're placing objects in this manner. All right, we're now looking at the code for this sword and shield issue that I was describing, and we're back now to this drop held object by tag function that we talked about earlier, but I said I would explain. And so here's the explanation. This is a really very simple thing that happened, but we can see this is on our main root puzzle controller. So this covers all levels. It'll happen. And it just goes through when we call it. We check to see if the right hand has been populated in the editor, if there is a grab target in the hand, and if that grab target is the object tag that we're looking for, then we call a force release function that drops the item from our hand. So again, as part of the Hexabody package, there is the ability to force the hand to drop it without the player actually letting go of the button. So if that's needed, it's there. So one of the other things that I mentioned at the beginning of this level was just an interesting collider issue we had with this sort of kind of stove type thing. This has a mesh collider on it. It is not convex because this entire chimney is part of the asset, and so a convex one would mean that we wouldn't be able to put assets on the counter. This particular fish that we see, we can pick up here, would be falling through there. And so our mesh collider, because of the way this is in the grates didn't actually have the collider and it would fall through. So we'll see just in a second here how we solve that. It's a real simple solution. All right, and here is the stove or the oven or whatever you want to call this asset in the editor here, and if we select it, we can see kind of the whole asset. And so just like I mentioned, if we made this convex, obviously that's not going to work with having to pull items from that particular area, right? The counter area wouldn't work that way, so we can't have it as convex. However, we can see now that the grate, as I mentioned, the collider actually didn't cover the grate. And so how did we end up fixing that? I created this kitchen grate collider, which is a invisible, a transparent collider that is just going through the grate items as well. And it's got a box collider on it that is then preventing the fish from falling through. So it's just a little bit of an extra help for that asset so that we get the desired effect that we want. Okay, so we've opened up the bookcases in the back here, and I just wanted to share and showcase the change that we did with the crates. If we remember from the previous video, when we grabbed these crates, it basically filled up the whole vision in front of the camera. You couldn't see where you were going. And I had said then that I would like to kind of implement where the object shrinks a bit when we pick it up. And we can see now if we do, it does. In fact, it's much smaller when we carry it around. We can actually see what is what when we're walking. As soon as we place it down, it grows again, and in this case hits the pressure plate. It doesn't matter where it is, you can drop it, it'll regrow. It just makes it so that we can walk with these things in our hands and not have to kind of go blindly. So this functionality where we are changing the size when we pick up things is done by a script. We'll just quickly review that as well. So it can be any object that we pick up. but obviously we don't have to implement it. And throughout the game, there are just a few things here and there, crates, barrels, boxes, a few other things, baskets, that I apply it to in order to be able to see as we walk. So let's take a look at the editor and the script for this one as well. Okay, and here is our object scaling controller. We saw the two variables in the editor with our serialized field. We've got default values, not very interesting. We've got a private variable, keeping in mind that this script has a new instance on each object. So we have its each object keeps a track of its original scale. We are using the HDR grabbable component, and then there's this coroutine, which I'll talk about in a second. And then we have this bool. So when we start, we get a reference to the grabbable component. We also get the original scale, and we add the listeners on the grabbable piece, the grabbed and the release, so that this script gets called whenever we grab something or release it. We have our onGrabbed function here. So whenever we force pull or pick something up, this function is called. We're just going to skip this part here. I'll come back to it. The part here is interesting because what I was having an issue with this was the backpack. And so I've actually got a conditional to say, is the game object name containing the slot, which is the backpack slots. So basically that this onGrabbed, not only does it get called when the object comes into your hand, but it also gets called when the object slots into one of the backpack slots. So that's like the onGrabbed is not necessarily just like a hand grab as we would know it. It's actually just the item going into either the hand or the backpack slot. So I wanted this scaling to only happen when it's the hand. So that's why we have this conditional here. We're just setting an isGrabbed to true to control that we're doing the scaling, and then we have our start scaling coroutine. Function. This isn't the coroutine yet. So let's just do the start scaling. This is where we can see if the scale coroutine is not null, we stop the coroutine. And again, let me come back to that part. We actually start the coroutine, scale over time with the target scale, and we set that to the scale coroutine. So let's keep that in mind. We'll go to the scale over time, and this is just a function that loops while the scale duration is not complete. The transforms the local scale according to time delta time, and then we exit out. So what happens? Basically, we're covering the fact that if we grab it and then release it in less than the amount of time it takes to scale to the smaller version, we then, in both areas, if our coroutine is populated, we stop it. Same thing on the start scaling. If it is not null, we start it, and we just set this to null once we are on release here. So this one's a little more complicated, but as we saw in the in-game usage of it, it's actually pretty smooth now. All right, well, thanks for joining. Appreciate it. That's all I've got for this devlog for now. We covered a number of things: the hand rotations, the fireball, lighting a torch and extinguishing the torch, and a few bugs, the scaling, all of that good stuff that's happened in the last little while. For the next one, which will probably be in a couple of weeks, I'm kind of hoping to start tackling menus again. There's a few bugs that are still outstanding. I also have to get some people playing it just to kind of pull out some of the things that happen when someone's actually in playing the game as opposed to the developer doing it. So again, thanks for joining. Hope to talk to you soon. If you haven't already, check out Ortunia Mysteries, Where Did Everybody Go, on Steam. It's available there now. Otherwise, it'll be available on the MetaQuest store relatively soon. Thanks again. We'll chat soon.